In this part of the lesson, we are going to look at counting significant figures. Now, significant figures is just an expression of the degree of confidence or precision for a given value. Let's say, for instance, we have three values, 23, 23.5, and 23.5682. Notice that the one with the most precise answer is this one. That is the one that you would have the most confidence in. Now, how does this apply to your work and your data? Let's say, for instance, again, we are required to find the amount of area in this space. And we have a value here of 23, as we have over there. And then we have a value here of 3.25. And we're required to multiply these two values. Let's look at it. 3.25 multiplied by 23, and my answer is 74.75. Now, when I have to state my final answer cannot state a more significant value than my least significant. In other words, I can't share a more precise answer with you other than one that has two significant figures. So I have to reduce my answer to two significant figures. 7.5 is my answer. Why is it that you cannot put an answer that is greater in significance? The answer is very simple. If this here only has two significant values, or I am only confident in this up to 2 digits, and I am looking at this number and I'm only having a confidence in that number up to about 3 digits, as you see here, 1, 2, 3. How can I state an answer that has a confidence of 4 digits? It's just simply not possible. This is why we say whenever you're stating the answer, you have to state the answer with the least significant of the data that you use. So if your data has, for instance, 2 values in one, 3 values in the next, 4 values, 7 values, then the answer must be stated to a significant figure of 2, because that is the number of least significance. Let's look at a couple of examples, and we'll go to 2 significant figures in each case. Okay, so we have 1 significant figure here, 2 significant figure here, and we cut off here. Remember, you are supposed to start counting from the first position that is greater than 0. So that's why we started at the 1. This number here after the cutoff point is what we have to observe. It is 5, so therefore we have to add 1 to this position here, and we will get 110. Now notice we have to put back a 0 at the end here in position where the 5 was, because what we are going to do is maintain the significance of the value itself. This number on top here is representing 105. This one here needs to be a representation of 100 and something, so that's why we have 110. Let's look at the next one. If it is that we start from left to right at the first number greater than 0, we have 1, 2, cut off here. Therefore, if we are cutting off at that point, we have to observe this number here. It is higher than 5, so we add 1 here. So we would have 0.0055. Notice we have to add the zeros in to maintain the significance of the numbers here.